So today's lesson is going to be about orbits. In our solar system, we have planets that orbit around the Sun, and we have satellites that orbit around the planets. Now, there are such things called natural satellites, we usually call these moons, and they orbit around the planets. I'm going to demonstrate this using a rubber bung, and that's going to be the planet orbiting around the Sun, and my hand is going to represent the Sun. So just to show you what I'm going to be doing, I'm going to be spinning the bung around my hand. And so the bung is in orbit around my hand at the moment. In space, the planet has a gravitational attraction to the Sun, and the Sun has a gravitational attraction to the planet. There's gravity between them. Now, between the bung and my hand, the gravitational attraction is so weak that I'm having to use the string. There'll be tension in this string. I will be pulling on the string, and the bung will also be pulling on the string. And so because of Newton's third law, we're going to have tension pulling both ways in this string. So there are three things that I can actually change with this. Number one, I can change the diameter. And so I can have a very small orbit. With a larger orbit, it actually requires less force pulling on my hand to keep the bung moving at the same speed. Another thing that I could change, I could use a larger bung or a more massive bung, a bung that has more mass, and that would require, obviously, a greater force to keep it in motion. And the third thing that I can change is the speed at which the bung is moving. So I could have it moving slowly, or I could have it moving quickly. And actually, moving quick requires a much greater force in the string. If we look at the bung itself, the only direction that this string can pull is towards the centre of the circle, and so towards my hand. And it's exactly the same in the solar system. If we think about a planet orbiting around the Sun, the only force that's acting on the planet itself is the force of gravity towards the Sun. Now, if I was swinging this round and I were to let go of it, you might imagine that it would actually fly off in a curved or an arced shape. It actually doesn't. It flies off, and it would fly off in a straight line. So if I let go of, if I just get a slightly slower thing, and I let go of this, and it flies off, it's an exact straight line, and that's because there's no forces acting on that anymore. So there's a couple of things that are key from this. It is gravity is the name of the force that keeps planets in orbit around the Sun, or satellites or natural satellites in orbit around the Earth. The size of the force required to keep the satellite or planet in orbit depends on the radius of the circle. Remember, the smaller the radius, the more force is required. This is because it has to change direction in a much sharper circle. Secondly, you need to remember that a larger mass object is going to require more force to keep it in orbit. And finally, an orbit that is moving faster requires a greater force to keep it in orbit. So that's enough demonstration of me swinging a bung round. It's now time for you to go and do some work. Goodbye.